Yes. Yeah. Good afternoon. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible, right? Right. Thank you. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in big data, Hadoop and Spark environment. So starting with what is big data? Why Hadoop and Spark? Why Hadoop and Spark? Why Hadoop? I'll come back to Spark. Drawbacks with the current databases. What is big data? Why Hadoop? Drawbacks with the current databases. Advantages of Hadoop. Advantages of Hadoop and Spark. Hadoop and Spark. Job market. What is big data? Why Hadoop? Drawbacks with the current databases. Advantages of Hadoop and Spark. Hadoop and Spark job market. Starting with the big data. The name itself saying like the name itself saying like huge volumes of data. Currently, the data is stored in the form of data storage units like KBs, MBs, GBs, gigabytes. Should have seen TBs of data, but today data petabytes, beyond that exabytes, etabytes, sotabytes, so on, right? So should have seen KBs or MBs or GBs or even TBs of data. But today data is generated in petabytes, right? One petabyte, one petabyte equal to 1024, right? 1024, right? TB. 1 petabyte equal to 1024 TB. Today data is generated in petabytes. Examples of petabytes of data generation. Talk about any banking sector like SBI. Within the city, within a particular city, you see hundreds of branches for SBI. Within the entire state, thousands of branches for SBI. Within the entire country, lakhs of branches for SBI. Again, within each branch, millions of customers making multiple transactions per day, per week, per month, and year, right? Each and every transaction has to be stored. Huge data is getting generated, right? Forget about this banking sector. You are aware about this social media like Facebook. Facebook has got users throughout the world, not only within the country, it has got users throughout the world. Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What is the data generated by Facebook in a minute? Not only Facebook, today, if we talk about a lot of applications are generating data in petabytes. For example, like Facebook is the one, Twitter tweets, Google queries, right? Data generated by Google in a minute. If I take 1 minute transactions, what is the data generated by Facebook, Twitter, Google, YouTube videos upload. YouTube today, everyone they are uploading their videos in the YouTube. YouTube videos upload. Email or Gmail messages. millions and trillions of users using this Gmail messages, right? What is the data and what is the storage capacity to store all these messages, right? Yes, huge data is getting generated here. Just now I was talking about bank transactions, telecom transactions, on e-commerce transactions, everywhere, right? Huge data is getting everywhere. You see, like huge data is getting generated. Currently, we have got databases like Oracle, MySQL, SQL Server. We have got databases like Oracle, MySQL, SQL Server, DB2. All these they are used for OLTP operations. OLTP operations, right? Online transactional processing. Online transactional processing for day-to-day operations. But we have got some specialized databases used for data warehouse purpose. Like if you heard about like Teradata, Netija, Vertica. Yes, these are Teradata, Netija, Vertica. These are used for data warehouse purpose. DWH. This is for OLAP operations, online analytical processing. But these databases are specialized databases. They can handle data up to some extent, but beyond that, they cannot handle the data, right? So as a solution to the storage level problems or processing level problems, we have got a framework like Hadoop, right? So before I go with this Hadoop services, right, you need to know something about the data, how the data is getting generated in the current real world. What are the sources? What are the types of data? You see, this is the data which has been generated from the last 50 years. This is the data which has been generated, right? From 1975 to 2025. Compared, one second. This is the data which has been generated. This is the data in the entire real world, which is available in the current world, which has been generated from 1975 to 2025. And if we compare the data from the last 1975 to 2015 and from 2015 to 2025, last 10 years data with the previous 40 years, if we compare, nearly the previous 40 years, only 20% you see. And the last 10 years, 80% of the data has been generated. Whatever data you are observing today, especially from the last 10 years, 80% of the data has got generated, but previously 40 years, only 20% of data has been generated. Okay. Reasons for huge data generation. Reasons for huge data generation, especially from the last 10 years, right? Because of usage of technology, because of usage of technology, because of usage of internet, because of usage of smartphones, because of usage of technology, internet, and smartphones. Huge data is getting generated, especially from the last 10 years. And this data, the huge data, mainly we have got three sources from where this data is getting generated. Three sources of data. social data, machine data, social data, machine data, and transactional data. Social data, machine data, and transactional data. Data which got generated from social websites, social data, right? Data which has been generated from the social sites like Twitter, Facebook, all these things, right? Machine data, data which has been generated by reading or scanning the RFID chips barcodes, right? Such data we call it as machine data. Yes. Transactional data, data which has been generated from day-to-day transactions, like telecom transactions, banking transactions, right? So these are the mainly three sources from where this data has been generated: social data, machine data, and transactional. And what are the types? Mainly, it is going to occupy three types, right? We're going to say three types of data. Structured data, semi-structured data, structured data, semi-structured data, and unstructured data. Structured data, semi-structured data, and unstructured data. Structured data, data which has been generated, data which has been generated from, okay, data which is organized in the form of rows and columns, like Excel files, DB tables, like Excel files, database tables. Semi-structured data, semi-structured data, data which is not fully structured, data which is not fully unstructured, right? For examples of semi-structured data, like JSON files, XML files, unstructured data like chart messages, raw text, articles, images, videos, all comes as unstructured data. So the biggest challenge today is to handle this unstructured data, that is storing and processing this unstructured data, where databases can handle only structured data, right? So as a solution to all the storage level problems and processing level problems, right? So we have got a framework like Hadoop. So Hadoop is meant for mainly two things: for storage and for processing. For storage and for processing. Is meant for storage and for processing. So if you talk about any technology, it is meant for either storage or for processing, like C or C++ or Java or .NET. They are meant for processing. Oracle, MySQL, DB2, All these they are meant for storage. Any technology is either meant for storage or for processing, but Hadoop is meant for both storage and for processing. For storage, does Hadoop use any databases for storing its data? No. We have got a lot of drawbacks with the databases. Despite of this drawback, still Hadoop doesn't use any databases for storing it. It's going with a kind of file system called Hadoop distributed file system. It is going with Hadoop distributed file system, and for processing is going with an execution model called as MapReduce. And for processing, it is going with the execution model called as MapReduce. Yes. So now coming back to this, right? For storage HDFS, for processing MapReduce, are currently we are going with Spark. Now, coming back, right? Yes. Why? Otherwise, drawbacks with the data, drawbacks with the current databases. Drawbacks with the current databases. Hmm. First one, very less storage, very less storage, no parallel processing, very less storage, no parallel processing in most of these databases. But if volume increases, speed decreases. But if volume increases, speed decreases. For example, if volume increasing, speed decreases means just observe this. Select a total amount. Select total amount from sales. From sales one, which has got 10 records, total amount from sales to 10 lakh records. Select a total amount from sales 3. Select total amount from sales 3. 10 crore records. Total amount from sales 1, 10 records. So total amount from sales to 10 lakh records. Total amount from sales 3, 10 crore records. So as volume increasing, right? Speed, which query executes faster here? Total amount from sales 1 of 10 records, right? As compared with 10 lakh or 10 crore. As volume increasing, speed decreasing here. Even complexity increases. If complexity increases, speed decreases. If complexity increases, speed decreases. Same thing. Select a sum of amount from sales 1 Select average amount from sales one. Select standard deviation of amount. Standard deviation of amount from sales one. Select total amount from sales one, average amount from sales one, standard deviation of amount from sales one. So here also which query executes faster means the first query, because second query is a two-step process. First sum to be calculated, next average to be calculated. Like standard deviation of amount from, so as compared to this first query to second query, third query. So query to query as complexity increasing, speed decreasing, right? The major drawback with this databases, right? Databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. They cannot handle unstructured, semi-structured data. Hadoop advantages. Hadoop advantages. Mainly like very high speed processing. Very high speed processing. See, Hadoop advantages, right? First thing, unlimited data storage, I can say. Unlimited data storage. Unlimited data storage. Very high speed processing. Yes. Can handle all varieties of data. Can handle all varieties of data. Structured, unstructured, and semi-structured data. Is an open source. No licensing required. Unlimited data storage, very high speed processing, can handle all varieties of data, open source, no licensing, right? Yes. And the commodity hardware can run on any hardware. It doesn't mean that it has to have highly configured systems. Can run on any hardware configuration. Hadoop is proven in the market with very high speed processing. So there were many tests conducted. Yahoo has conducted a test, has taken a table of 100 TB of size consisting of 1024 columns, task sorting based on 16 columns, sorting based on 16 columns. Time taken, right, by different databases. Oracle has taken nearly 3.5 days to process this. MySQL has taken nearly 6 days to process this. Teradata, a specialized database used for data warehouse, has just taken 4.5 hours. Netija, another specialized database used for data warehouse, just taken 3 hours of time. Oracle 3.5 days, MySQL 6 days, Teradata has taken 4.5 hours, Netija has taken 3 hours. And finally, Hadoop just taken 3.4 minutes. So this is what the speed of this Hadoop as compared with the other things, right? Where Oracle has taken days of time, Teradata Analytics has taken hours of time, Hadoop has taken minutes of time. Very high speed processing. So as part of this course, we'll be discussing about this big data Hadoop plus Spark with Python, PySpark, Linux, and also a programming language like Python, right? It's both core and advanced. I'll come back to this. If you want to check this course content, just check this course content, right? Just a minute. Yes, just observe this course content. Okay. See the check the course content also pasted in the chart, right? In the chart, you can see that. So here you can just observe this course content. What is big data? What is Hadoop? Need for Hadoop? Sources and types of data. Comparison with other technologies. Challenges with big data. Databases in Hadoop. Advantages of Hadoop. Hadoop ecosystem components. HDFS, Hadoop distributed file system. Features of HDFS, name node, data node, right? HDFS architecture, metadata management, storage and processing, replication in Hadoop, configuring custom replications, fault tolerance, HDFS commands, map reduce, scoop X for importing and exporting operations, scoop import, scoop export, importing data from database to HDFS, from database to Hive, exporting from HBase to RDBMS, from HBase to this, and filtering data, vertical and horizontal matching, yarn, yet another resource negotiator, NoSQL databases, different types of NoSQL, one NoSQL database like HBase, and also one of the important component of Hadoop Hive, right? It's a kind of data warehouse kind of environment. Lot of jobs available only on this Hive component. We can see this Hive just in the Chrome, right? Hive jobs, you can say. Just type Hive jobs. Lot of jobs for Hive. 12,702 Hive job vacancies in January, right? Yes. Loading data from the Hive tables, internal tables, external tables, working with XML data, working with JSON data, Hive URL web block processing, Hive UDF, Hive UDAF, UDTF, right? Partitioned tables, non-partitioned tables, And also like streaming data and technologies, I'll be discussing like Kafka. Streaming data means data which keeps on incrementing, which keeps on generating. Such data we call it as streaming data, which keeps on generating. And PySpark introduction, need for PySpark features, PySpark RTD, parallelizing, repartitioning, broadcast variables, PySpark RTD computation, persistence options, PySpark core computing, grouping segregations, various actions, transformations, PySpark SQL data frame, select, collect with column, all this, right? All this. PySpark SQL functions, built-in functions, one by one functions with working examples, PySpark external sources, deployment modes, PySpark application, stages and task drivers, and PySpark streaming and integration with Kafka and PySpark ML. And also like Python basics, Python operations, operators, IDs, different types of IDs like Jupyter, Spider, Eclipse, NetBeans, flow control statements, looping statements, strings, collections, Python lists, tuples, sets, dictionaries, functions, right? And modules and modular programming, packages, errors and exception, file handling, object-oriented programming concepts, regular expressions, database connectivity, Python date and time, OS module, advanced concepts like iterator, generator, closures, GUI programming, and Excel workbook, data analytics, introduction to data science, pandas, and NumPy. Okay, so these four components, right? Hadoop, Spark, Linux, Python. So this big data, Hadoop, PySpark, and Linux, this will be dealt in the weekends, nearly 12 weekends, right? Around the 3 months. The fee structure is 15,000 for all these like four components. And this Python Core Advanced, there will be separate sessions. For this, you need to attend from Monday to Friday. But this will be only on the weekends, Saturdays and Sundays. So the timings of this batch will be like first, initially first this week and next week it will be at 3 p.m. But later it will be starting at 5 p.m., 5 to 7. The timings for this will be 5 to 7, right? You will be getting the session videos, each and every session videos for all this, right? Soft copy of the notes, class notes, soft copy of this class notes, and a WhatsApp group for technical discussions, right? Assignments or tasks. Assignments or tasks to work with. Interview questions. Okay, fine. You can check in the chat, right? The message given by the online team. Their contact details, payment details, course content details, everything are provided in that. You can check with that. Yes. Tomorrow also you can attend that. So introductory session, right? Tomorrow also you can attend the session. Same time at 3 o'clock using the same link to see more discussion on this, right? Yes. Any queries from your side anywhere? Okay, fine. Apache Pig is there, right? Apache Pig was there. Previously, Apache Pig was used a lot. But now when Apache Spark was introduced, the pig got outdated, right? Apache Pig, we say. The pig Latin language. If you want, I can also give some knowledge on this pig. It's not alternative of Hive. Hive is mostly used today. Just I was showing you Hive jobs, not for alternative for that. Pig, it was a scripting language, right? Big Latin language. Previously, it was used a lot. You go back like in 2014, 15, 16, 17, Pig was used a lot. But later, once Spark was introduced, the Pig got outdated now. It's not, it's got outdated. Spark is mostly used. Okay, fine. So tomorrow we'll discuss more on this. So you can join the session tomorrow, same time at 3 o'clock using the same link to see more discussion, right? Thank you for your time. Meet you tomorrow.